some lights here. Okay, so what I'm going to do today is just give you a quick review, the things will be covered in the exam. And you have the simple exam. I'm going to go over some of the problem in the simple exam. And then if you have any question that I can answer your question. Um, Other than that, I think on Friday, the exam will be in the GE building, the new building with the big lecture hall. You just go there, and exam start at the 9 in the morning, and it's a it's 100 minutes exam, so it's not like an hour because you add more material, which you will include the chapter 4 as well. So I make it like 100 minutes of exam. And you just go over there at 9 o'clock. Everyone has to put on the mask. We do have some students get COVID. So if you don't feel well or you have the exposed to some others might have the COVID, then please let me know. Then we can make some other arrangement for you to take the exam. We has to be very careful about this, and so please, if you um, have some concern, please let me know so I can make some arrangement. Any question about the exam? Okay, Friday, 9 o'clock. I'll see you in the GE building 225, the GE 225. Let me type it here. Just make sure everybody know. Okay, so that's the 225, not 226. All right, the exam cover the material from chapter 1 to chapter 4.4. If you log into Canvas, there's a page called the exam resources. So you can find the solution for the previous homework. You can also find a formula sheet. Let me change the screen to that. So I wanted to make sure that you know what kind of thing they can find from Canvas. So let me change my screen to.
Professor,
Yes.
we have studied a part of that chapter 4, 4.1 to 4.4. It's going to be
Yes.
in the exam, right?
Yes.
Um, but the chapter 4, they have many parts later. We just cover from
We
40.
just cover the node voltage method.
Okay.
So if you look at the canvas and you click on the week 4, and there's a page called Exam 1 Resources.
Yes.
You click on this one here. These are all the solutions. The solution might not be the same as the homework that you have to do on Canvas. Just for your reference. And this one is something that you might want to pay attention. This is the formula sheet I'm going to give you in the exam. So you're not supposed to bring anything. This page will be printed out. I will print it out for you. So this is the only page that you're going to have in the exam. That include the basic definition of the I current voltage, the power, uh, and you know how to get energy, right? Integration of the power with respect to time. Transformation equivalent pi to delta, or no, it should be delta to pi or pi to delta. So this is the transformation equation over here. The current division, voltage division, there's a integration table over here. Uh, so that's the equation, that's the formula sheet that you're going to get in the exam. If there's like some kind of constant that you need, like, well, you're supposed to know, but if I ask you like electron, how much of charge of the electron, this is 1.6 times 10 to the negative 19, then I will give you that as well. So you don't need to memorize those things. Any question about that? there's some of the worksheet I include over here, which is a good resource for the review if you want to review those things. And I want to put emphasis on the sign convention. So a lot of people make mistake on the sign convention. So you might want to take a look as well. And there's a solution over there too. How many problems are you going to get for the exam? It's very similar to the simple exam. You might have one more question on the chapter 4. So that's pretty much like the number of the question that you're going to get. So it'll be one additional to the simple exam that you have. Okay, so that's the resources. You can take a look on yourself. Again, the homework problem solution might not be the same as the one that you have on the Pearson. It just for your review, if you haven't finished the homework problem. Again, if you haven't finished homework problem, the penalty is very small, but you should finish them. Okay, it's a building block. It's really a foundation for the rest of the courses. So make sure that you finish those things. All right, then I am going to move back to my note and then we will start the review. Okay, these are the topics I'm going to talk about. Let me just give you a brief review about the material that you should know about this exam. So starting with the fundamental definition of the parameters, we're going to come over to this fundamental definition again as well when we talk about chapter 6. And these just tells you once you have one of the property, how you get the other, and based on the definition. The current is the rate of change of the charge. Voltage, which is electrical potential, is the change of the energy over the change of the charge. And the P is the power, which is a V times I in general, and is also equal to the efficiency of delivering of the power, which means is the d omega over dt, where omega is the power. So these are the basic definition that you should know because that's something that you learn in the physics as well. So these are the basic things that you need to know. Um, then if pay attention when you do integration, right? When you do integration, you're supposed to have an initial value. So if you integrate the energy, which is the omega, then you should have an omega zero. That is the initial energy stored in the device. So don't forget about that. If that's the case, then you have to get this one to get the solution. Same thing for the current. If you are looking for the charge, the total charge, then you also have to include the initial charge in the device if you are given with a current equation. So these are the things have to be pay attention to. And I give you an integration table unless I think you know polynomial integration. So I'm not going to give you that kind of equation that you should know. Um, Sign convention, this is important. So how do we define the direction of the current? How do we define the direction of the voltage drop? And all those things you should know. And if you're not sure, you can look at the sign convention worksheet, or you can go back to our lecture to make sure they understand that. Now, the current is the most important one. If you have a current, you want to find out the direction of the current. The current is from high voltage to low voltage, right? So it's from positive to the negative. That's the definition of the current direction. Voltage drop, if you go from low voltage to high voltage, that's voltage gain. So voltage drop meaning is from high to low. So capacitor always give you a voltage drop because it's from high voltage to low voltage. Whenever you see a capacitor, and if you know the direction of the current, then the capacitor has the current goes in is always positive. The other end will be always negative. That is the rule to find what is the direction of the current and also the voltage drop of the capacitor. Um, all right, so what about the power? The power probably is the one that most of the people will make mistake. We talk about the power. When you are looking at the power, you look at how current is flows into or flows out, and then you are looking at if the current goes into the positive, will the power be positive or negative? If current go into positive, are you going to have a positive power or negative power? Any, no one knows, or you don't want to answer it? Okay, power. If current go into the positive terminal, then is a positive power. Positive power meaning is a power sink, is a power it consume power is the device will use the power, which is the resistor. So the resistor always have positive power. If the current go into the negative and normally is the source, then the power will be negative. So when power is negative, meaning is a power generator, is a power source. But sometimes the power source looks like it's a source, sometimes it's not. It could be it could be a power it could be a rechargeable battery that you need the power actually to charge it. So don't ever just assume that whenever you have a source, it's always be a power generator. Sometimes it's also going to be a power consumer as well. So resistor always positive, but for the rest of the object, you have to look at what the current direction is. And that's how you determine the direction of the power. Okay, any questions so far? I need to change my screen to my pad so I can write something. So I'm going to spend a little bit time to change my screen right now. In the meantime, if you have a question, you can ask me or okay, I need to.
Professor, we can't hear you.
I'm sorry, I forgot I turned off my mic. Can you hear me now?
Yeah.
Yeah. Okay, thank you. All right, so I was talking about the parallel and series resistor. I didn't give you the equation in the formula sheet, but I think you should know. In series, just something together. In parallel, you have this very easy equation to use, but this only works for two. So if you have two resistors in parallel, you can always use this equation to find a solution. The voltage and current division, I give you the equation in the formula sheet. Just need to know the voltage is proportional to the resistor. So if you want to find a voltage of 1, and you put a 1 resistor on the top. If you want to find a current, which is inverse proportional to the resistance, higher of the resistance, get smaller current. So you want to find a 1, and on the top will be the second one. But this only works for, this is an equation for 2, right? So if you have 3, then you need to use the general equation. The general equation is very similar. You simply just use the Req and also the R of the resistor you're trying to find. You can always combine the rest of the resistor into only 2 in parallel in series. So you can always use this equation to find a solution. And this one here, the transformation, you're going to have one question on this delta to pi transformation. So make sure that you look through some of the example and try to use those equations. It's not like a very difficult, but just try some of the example, then you should be able to transform the circuit into another circuit which you can solve. When you transform to another circuit, your goal is you can make that circuit into a combination of the series and parallel, and then you can use those shorthand notation to find the equivalent resistance. And that's the goal, to use this transformation. And the no voltage method is the last thing that we talked about last time. And the idea is that you use the KCL because KCL works on the node. And there's a procedure that I give you. So make sure you go through the procedure, work on some example to get familiar with the method. It's really a very simple way to solve a circuit. It's a node, it's a KCL, but you solving voltage. You solve the node voltage. And this node is what we call the essential node. So it's not like the node only connect with 2 elements. Essential node is the node with 2 or more, should be 3, at least the 3 elements connect to that node. That's what we call the essential node. You express the current in terms of a voltage and the resistance. And this is the equation that we told you. If you wanted to write the current of between 2 nodes, let's say you are looking at node from 1 to 2, and this is the current from 1 to 2, then you're going to use the voltage of 1 minus voltage of 2 divided by the resistor. Okay, so it's from -2, 1 minus 2 if the current is flow from 1 to 2. The resistance is the resistance between the node 1 and node 2. The supernode is a special case, and you're looking at voltage source. If you have a voltage source between 2 essential nodes, and that is going to be a supernode. You cannot use just no voltage method to solve it, because when you try to solve it, you will have a situation where you don't know the current in the voltage source. A voltage source normally give you the voltage difference. It doesn't tell you the information about the current. And you don't know the resistance as well, so you cannot use Ohm's law. Therefore, you have to use a super node method. Super node is a node that you have two terminals. So you have one node at here and the other node at here. This node, let's say, is V sub 1. The other node will have a different voltage, which is a V sub 2. And you can have several connections to each one of the node. For each one of the node, you have to write a current equation based on the voltage that is connected to the super node. So you have to use another way to get the solution. Now, super node itself will give you one additional supplemental equation to help you to solve this problem. And that equation is that based on the source. So if you have a source, let's say you have a source at here, and this one give you like a 10 volt, it simply just tells you from voltage 1 to voltage 2, you have a 10 volt of difference. Now, the question is, what kind of equation are you going to have? How do you relate V1, V2, and 10 if I give you this one here? Which one has a higher voltage? If you start with the V1 and you go to this voltage source, are you going to have a voltage drop or voltage gain?
Drop.
You have a voltage drop, that means you have a V1 minus 10 will be equal to V2. Okay, so make sure that you understand this one. Otherwise, if you write wrong equation on this one, the whole problem is wrong. Your whole answer will be wrong. So think about, is a voltage drop or voltage gain, and which side has a higher voltage, then you should be fine on this equation here. All right, any question about the topics that's going to be covered in the exam? Okay, let's look at some of the simple question I give you for the simple exam here. The multiple choice question, first one is so simple. I don't think I'm going to give you this kind of question in the exam. But you should know that there's some like a symbol that we use in the circuit, like the mu, which or the mini, right? 10 to the negative 3, or micro, 10 to the negative 6, or narrow, 10 to the negative 9, and pico is 10 to the negative 12. All these things that you should know. So make sure that you use the right exponents. The second one here is talking about the power. So if you want to find the voltage they give you, and they give you the current, what is the k-watts? What is the unit for the k-watt? Is it the power, or is the energy?
Power.
It's a power, right? So if that is the power, and you can find a power, which is simply just a V times I, and you're given with I, you're given with the power, and all you need to do is to find a V. So this one should be very simple, and you can find a V, right? Number 3 is a very simple circuit. Now you have two sources. These two sources are independent voltage source, and they give you the current, right? They give you the current direction. Now the current direction they give you is go to the right. However, if you look at the circuit, well, the voltage on the right is actually larger than the voltage on the left. So the current's actually supposed to flow from 5 to 3. But they give you the direction to the right. So when you solve the circuit, then you're going to find out, well, the current is going to be negative, which will justify the actual direction of the current. So This just tests your understanding. Don't just take the current direction from the problem. When you solve the problem, if you get negative value, you just put the negative value. It simply just tell you where the direction of the current should be. Now, how do you find this one here? Well, if you actually want to solve this, then you should write a KVL. So this is a simple KVL. A KVL looking at the loop. Now, the whole loop, you can assume the current is the current they give you. If you follow this current here, and then when you have this positive, then you're going to have the positive voltage. When you go to the negative, you just go the negative voltage. So if I go to the 5 volt, I just write 5. And I go to this one here, this one is going to be also going to be positive. Then I have the 6 times I. And you go to here will be negative, then you just write -3 and go to this resistor is going to be a positive, and the voltage of this one is simply just 4 times I. And you make that equal to 0. Now, some people don't like this method. Some people want to say, oh, I wanted to just look at the voltage, or they have voltage drop or voltage gain. People prefer to have a voltage gain to be positive. That's fine. You can use voltage gain as the positive. I'm using the other way. But if you wanted to use the positive to be the voltage gain, you have to be consistent. When you have a voltage drop, you put a negative. So if that's the case you want to use, and you can follow this, when you go from here to here, you have voltage drop, right? So that would be -5. When you go through a resistor, you have a voltage drop that's going to be -6I. When you go to the 3 volt, you have voltage gain because it's negative to positive. Then you put +3. You go to the 4 omega, it's voltage drop. Resistor always cause the voltage drop. You put -4I equal to 0. This is going to be the same as the previous one. Whichever the method that you prefer, you can use either one. Just make sure some should be drop, some should be gain. Question about this? All right, the next one is to look at the voltage of this one here. Now, this is going to be similar to the one that we just told you. You can use the KVL equation as the one that we just did. Okay, so if you use the method that I told you previously on the first equation that I wrote, and you follow the direction of the current. Now, you can assume any direction of the current. Let me just assume current direction go this way, clockwise. And if I look at the first one, which is the 10 volt, and because it go into the positive, I'm going to write the +10. And the second one is the 8, is +8. The third one is a V, which is the one that we try to solve, but it go to the negative. So you're going to write negative of V. Let me just use a bar on top to distinguish the V, the variable, and the voltage. Okay. And then you go to a 12. Should you put a negative or positive? In this case, if you follow through my way, it's going to be negative, right? And that's very simple. This is a simple question, and you should get the correct answer that voltage should be equal to 6 volt. Okay, now this is just a basic test about your understanding about how to use the KVL and KCL, follow the current direction, make sure the current drop, make sure that's voltage drop or voltage gain. The last one asks you about the question of connection. So if you wanted to make a connection, you wanted to measure, what do we try to measure? We try to measure the current. So current, you should put it in series. And the correct configuration should be B, right? B is in series. If you put a meter on A, that should measure the voltage. So this measure voltage, this should measure the current. This should be the ammeter. I should write A here. So that would be ammeter, and the other one would be the voltmeter. Now, if you wanted to measure both things at the same time, then you should measure, you should put a voltmeter in parallel with the device as well, right? Okay, now in the lab, we told you different combinations. So you could have what? You could have a two different scenario. Let's say this is a light bulb here, and you can also put an A in here and put a V in here, and which one give you a better result? When I say better result is more accurate result, right? So you have to consider that internal resistance might cause the difference of the voltage that you measure and might cause the difference of the current that you measure as well. So it depends on what kind of thing that you measure and depends on how the configuration is, you're gonna get different results. So make sure that you understand how to make the correct connection. Okay, any question about the multiple choice part? Okay, the second part we're gonna look at are the calculation problem here. The first one here, I think is very simple, that you have a circuit with resistor in series and in parallel. And we want to find an equivalent resistance. So how do you find that? You can use the shorthand notation that we give you. So you can start from the outmost. So when you look at the R3 to R6, and they actually represent in this way. So that is the similar, it's the same way as you have on the right-hand side. The 3 to 6 actually connect in this way. So if that is the case, then you can write a shorthand notation for this part here, which is simply R3 parallel with R5. And they're in series with another 2 in parallel, which is R4 parallel with R6. Right? And then you connect this one to the R2, where the whole thing is parallel to the R2. So this whole thing is parallel with your R2. Then the whole thing is in series with R1. So you plus R1 at the end. That will be your R total or the R equivalent or the R between 2 terminal. That is your R total. And they give you all the value. You simply put the value inside of this equation. I think I don't need to walk you through this calculation. If you put all the number in there, you should get the result, which is going to give you 2.36. So the RT is 2.36 omega. And the question also gives you what happened if the current, we want to find a current, right? So we want to find a current if the voltage is 12 volt, which means what happened if I put this one here, this V, which is 12 volt, and can you find out what is the current that will go into my circuit? And that's very simple. That's simply, the current is simply R V equal to IR, right? So I will be V over R. So that should be V over R. And then you put 12 volt divided by 2.36 omega. That's not 5 amp. It is
5.08.
5.08. Okay, so that should be 5.08. Okay. All right. Any question about this one? That should be very simple. That 20 point, you have to get this 20 points. If you miss this one, I will be very sad. Okay. The second question here. Now, this one here that we ask you about the some fundamental definition about the Q, I, and V, and also the power and also the energy. So they give you the Q. This is a chapter 1 problem. The Q represent the charge, right? And as a function of sine function, it's not like a simple polynomial or exponential, it's a sine function. Now V is also a sine function. So the first thing you know, like a Q, when you are given with Q, and Q is related to current. I can find a current just based on this equation, right? So what is the current equal to? Well, by definition, current is dq over dt. And the Q is given, then you just take the differentiation of that. And notice this. What is the n here? This n here represent 10 to the negative 3. A lot of people will miss that. And you're going to get some points off. Just okay. It's a lot of time we have the milliamp, and people just only look at the amp, doesn't look at the amp. So this is something pay attention to. So this one here is not going to be, the result is not going to be in coulomb, because when you divide with the T, you don't get a current, because current is a C divided by second. Differentiation of this one, sine will become a cosine, and you don't need to put a negative sign, and you have to modify the phi with the 4 pi, and that will be the cosine 4 pi t. And this has to multiply with 10 to the negative 3, and that will be the amp. So that will be the result of the current equation, right? We want you to sketch the current. So once you have this equation, then you can sketch the current graph on this picture over here. Now the x-axis represent the time, y represent the current. So this is your current. And how do you draw this? Well, you see that on the graph, they give you like pi over 2 pi, and 3 pi over 2. So you replace the time with each one of this. Let's say time is equal to pi over 2. And you're going to have a 20 times 10 to the negative 3 pi, and cosine 4 pi times pi over 2 amp. And this part over here is what? Is, wait, really? 2 pi square? Okay, that's 2 pi square. Okay. Okay, so that is the value of that. Then you just use the calculator to find the value. So you pick several points on the graph to find a value, then you can come up with the graph. Okay. Now, if you have a MATLAB, then you can write a simple program to plot this. It's very simple, actually. I didn't calculate each one of them, but I think you got an idea. Then you just simply sample of this with a different point. If you have a 0, what will be the value starting with? Are you going to have a value at the time you go to 0 or not? When time is equal to 0, the cosine 0 is equal to 1. So you should get an I at the time equal to 0, which is equal to 5 times 4 pi times 10 to the negative 3, which is a 0.02 pi amp. That should be the starting value that you have on the graph. So it should be starting from a certain point like this. And that will be a 0.02 pi. Okay. And that will be the largest value. And then you're supposed to see like a similar graph like this. Okay. Now, exact location that you're going to connect to 0 or not depends on this equation that you plug in the time. Okay. Question about this one here. Okay, now the next thing here require you to do some calculation on the calculus. The part B, we wanted to find the power delivered to the element at a time equal to 0.3 seconds. You have to use the definition of the power. The power is a function of time, is the V times I. Both functions are given, well, they didn't give you the I, but you find the I from the Q. So your voltage is 3 cosine 4 pi times T. And your current equation is 0.02 pi cosine 4 pi times T. Okay. Now, if I give you this problem, I guess you also need to know how to, you probably need some like a trigonometry identity equation. When you have a cosine multiplied with the cosine, what will be the equation to that for that? So I will give you that equation as well, so you can find the solution. But even if you don't have that, you can still solve this, right? Because I only look at the time equal to 0.3 seconds, and which means you already have the power equation. You just need to say, oh, what about time is equal to 0.3? Then you have 3 cosine 4 pi times 0.3 multiplied 0.2 pi and cosine 4 pi times 0.3. And that's your power, right? You don't really need to do anything else. Just need to combine these two. Okay, question about this. Now, the last thing here you have to do is to find the energy. Now, how do we find the energy? Well, we only know the power is equal to the omega over dt, where omega is your power. That means you have to do an integration. So if you integrate this equation, you get omega equal to omega 0 plus the integration of the power dt. The power equation is this equation. And that's where you're going to use the integration table. So the integration table will give you this kind of a equation, how will be the result looks like. Now, we also should give you the initial energy. Let's say if the omega is 0 equal to 0, then you can cancel this one out. Then all you need to do is to do the integration, and you will integrate from t equal to 0 to t equal to 0.6 seconds. If you look at the table now, let's just write down that equation. So the equation here is going to be, this one is going to be 0.06 pi, and you have a cosine square 4 pi t and dt. So that's the equation you need to do the integration. And if you look at the table, it's going to give you this formula. Okay, so you can get this equation from the integration table. If you want to take the challenge, you wanted to derive this equation, it's up to you. But I would just use that equation directly. And all you need to do is to make the t equal to 0.6 and find out this result for the definite, this finite integration. So the result is going to be 5.43 joule. Okay, I'll let you verify the result, but this is how you can find the result from this problem. Question about this? Okay, you might have one question about this basic definition. So I don't think it's going to be difficult. Probably the difficult part is the integration and differentiation. Differentiation, I think, is simple. Most of people make mistake on the integration. So just be careful and know how to use the integration table, then you should be fine. Okay, the next question. And this question is the question that you might also expect during the exam. Then I'm looking for how you do the transformation from either pi to delta or delta to pi. Now, when you look at this problem and you can identify there is a triangle, there's also a y or pi, y or t in this configuration, right? So if you look at here, this is your y or your t. But if you look at here, this is your triangle, or the bottom is also a triangle. So either way works. So it depends on how you wanted to do the transformation. It will always be able to transform that into another shape. Now, if I wanted to do on this problem, I will probably just do the t to the delta. So let me just clean this one up. Let me draw what this looks like. So here I have a t. I wanted to change to a triangle. When I change it to a triangle, I am going to I'm going to ignore the t, but it's going to become a triangle and will be look like this. Okay, this is the t go into a triangle. When you do that, then this 3 resistor, you have to give a name so you can use the formula to get a solution. Now you have to denote which one is the A and B and C in the formula. So if I use the top one to say this one is the node A, and I use the bottom one to be the node B, and this one will be the node C. And the resistor, the new resistor will depends on what the side is opposite to the corner angle. So the C, the opposite side of the C is going to be the RC, which will be the RC here. Similarly, this will be RB, this will be your RA. Now, the next thing is that when you use that equation, you have to identify which one is the R1, which one is the R2, and which one is R3, right? So based on the rule, the one that connect to the A is R1. So I know my R1 is equal to 50 omega. My R2 is the one connect to the node B, which is the R4 in this picture, which is 20 omega. My R3 is the one connected to the C, which is 50 omega. So now you have these 3, and you also have this configuration, and you can find out the RA, RB, and RC. So look at the equation. The equation requires you to do a summation of Ri, Rj, right? So it will be easier for you to calculate those things if you calculate this one first. So this one simply represents 50 times 20 plus 20 times 50 plus 50 times 50. You sum all these together, this will be the summation of the every pair of the resistor, which give you 4,500. And the RA, which will be the summation of that divided by the R1. So, and the 4,500 divided by 50, and that will be the RA, which is give you 90 omega. Similarly, you can get RB and RC. So RB is going to be 4,500 divided by 20. And this one is 4,500 divided by 50, which is 90. And this one here, you do the calculator, you'll get 225 omega. Then you got all this resistance. Okay. Now, be careful on this one here. Once you replace, what are you replacing is, you're going to make these things disappear. Okay. But you also have the R2 and R3 still there. The 25 and 30 is still there. So it's not disappear. So don't ignore those. And then you look at the circuit. Now the circuit is going to have the 25 in parallel with the RB, right? So let's just write the equivalent resistance based on this configuration. Now, after you do the transformation, then you know that you have RB parallel with the R2, and it's going to in series with R, that should be R3, I think. Yeah, the RA in parallel with the R3. And this whole thing is going to be in parallel with your RC, and then they has to in series with 13 and 7, which means you have to add 13 and add 7. So that's your RAB, the total resistance of the circuit. And if you do that, it's going to give you 50. Okay. Any question about this one here? You can try to do the other one. So you can try to make the triangle into a Y, and it should give you the same result. Okay. I think that will be a good practice if you wanted to make sure that you understand how to use this method. Try the same problem and see if you got the same answer by changing the triangle into a T, into a Y. Okay. All right. The next question over here I'm going to talk about is the either using the Kirchhoff law to find a solution of this circuit. Now, this circuit, we kind of talk about similar circuit like this in the class. You actually have two parts of the circuit, right? What is the current I0 equal to?
0.
It's equal to 0. And the reason is because they actually just a wire and they run independently. Their voltage should be the same at the bottom, so there's no voltage difference. I0 will be equal to 0. So the key on this one here is actually I0 is equal to 0. Once you have the I0 equal to 0, and then you have to you can solve the problem by looking at the left-hand side first. So if you look at the left-hand side, it's independent. So because they just simply a wire with no voltage difference, so you can treat it independently. On the left-hand side is a simple circuit. You have an 18 volt and you have a total resistance is 12 plus 6, right? So I can say I have a current going here, and this current is equal to your 18 volt divided by 12 plus 6 omega, and that give you 1 amp, right? And then you want to find a voltage. This voltage is important because this voltage is the one that the dependent voltage depends on. So you need to find a V delta. Now we can find a V delta, which is equal to 6 times I, that is equal to 6 volt. So you find this one is 6 volt. You can also use the voltage division. So if you want to use the voltage division, then you don't need to solve I. So the V delta use the voltage division is going to be the total resistance 12 plus 6. On the top, you're going to put whatever the resistor resistance is times 18 volt, and that should give you the same thing. That should give you a 6 volt as well. So either way will give you the same result. And then we look at the right-hand side, the right circuit. Our goal is to find the current 1 and current 2. So how do we find the current 1 and current 2? Well, what kind of a dependent source this is? Is this a current source or is a voltage source?
Current.
It's a current source because the arrow tells you this is a current source. We also have a special name for this. This is a voltage control, a current source. Okay, it depends on the voltage, depends on the voltage of something else. So it's a voltage control current source. And you can find a current. So this current is equal to the 6 volt divided by 3, and that will be divided by 2, sorry. So that'd be 3. Now the 3 going to be 3 amp. Okay, just ignore the voltage unit. So whenever you divide that, the value is going to be in amp, unless they say this is a milliamp. So this will be 3 amp based on the voltage. Now this amp is the current, but the current is going in this direction. So you have to know this is a 3 amp going into this direction. Now, once you know this, then you can use KCL on this junction over here. This is your junction or your node. On this junction, I use KCL. I write summation of the current equal to 0. So I have all current leaving. So you can write 3 plus I1 plus I2 equal to 0. Now, this doesn't help me a lot, right? I don't know what this current is. How can I solve this? Well, actually, if you look at the circuit, you can use the current division because it's a current parallel, has a 2 parallel resistor, right? But also, you also know because the current, the net current is 3 amp, and the net current is going counter is clockwise, right? The net current is going this direction, which means that these two directions, the I1, I2, actually the value will be negative because the current direction should go upwards instead of going downwards. So you can just simply use the current division to find a current for each one of them. I use current division. And my source current is equal to 3 amp. And my I1 should be equal to, you have a R1 plus R2 is 10 plus 5. When you find I1, you use R2. R2 is 5. And you multiply it with 3. And also make sure that you know that direction of the current should be negative, because we know that direction, you can't have all direction leaving, right? So this one will give you 1/3 times 3 negative, that's negative n, 1 amp. And I2 will be negative 10 divided by 15 times 3, that will be negative 2/3 times 3, that will be negative 2 amp. And then you got the solution for this one here, okay? So that current should be negative 1 and negative 2. That should be negative. I forgot to put negative here. Okay, The last thing we want to find is the power. Let's say I want to find the power of the phi omega. I want to find power of this one here. Now, don't confuse with the current direction. When you want to find the power of the phi omega, it's always going to be a positive power. So the power of the phi omega is always going to be positive, and it's going to be I squared times R. Why this is always positive? Because it doesn't matter current is negative, positive. When you put a square, it's always going to be positive, right? Same thing for the voltage. If you use the voltage, which is also going to have a V squared divided by R, doesn't matter voltage is negative, positive, you always get a positive power. So this one is very simple that you have current, which is 4 times R, which is 5, that's 20 watt, right? The current is equal to 2 squared times 4 times 5 is going to be 20 watts. Okay, question about this. Over here, I just give another like a question I wanted you to review for the no voltage method. So in this circuit, if you remember how we do the no voltage method, is the first thing we identify the essential node. So how many essential nodes that I have? This one is not essential node. This one is an essential node because all things connect to the bottom. You have 3 things connect together. This bottom one is an essential node. This one is also an essential node. So I have one in here, I have one in here. Do we have any other essential node in this circuit? No, we only have a 2 essential node. So identify 2, right? Now the second step is you're going to assign one of them to be the reference node. So it's ground, okay? So the ground at the bottom. So I assign the bottom one to be the ground. The step 3 is that you are going to denote each one of the node, which is a non-essential, with the voltage, and you're going to use the KCL on that node. Now, over here, they put V1 and V2, but you actually, if you think about the essential node, you only have the V2 is an essential node. V1 is not. V1 just a regular node, okay? So when you write a KCL, we write a KCL at the V2, okay? Now you look at the V2. When you look at the V2, you assume some of the current. So I have a current coming from the right, which is this one here. This is a 15 amp. I also assume there's a current going from the top to the bottom because bottom is 0, high voltage should be on the top. By assuming V2 is positive, then this will be the current. So let's just say this current is I sub 1. Let's say this is I sub 1. Now, I also have another current might goes to the left, right? So let's say I have another current go to this direction. Let's just say this is I sub 2. All right, so after this, then you write a KCL equation. Now the KCL equation give you current goes in equal to current goes out, or current goes in is positive, current goes out is negative. So if I do that, then I have a 15 amp, which is positive, that goes in, minus I1, minus I2. Okay. All right. How can I solve this? The I1 is simple. The I1 that is the current from V2 to 0. So this one is V2 minus 0 divided by R, which is 30. Okay, what about the I2? Well, how do I write the I2? Well, when you do the I2, you have to look at the voltage, right? So I starting with the V2, but then I go into a voltage source. Will this voltage source give me a gain of the voltage or give me drop of the voltage? Are you gain voltage at 600 or you lose 600 voltage? You're going from low to high, so you actually gain voltage. So you should plus 600. And when you go to the end, it's going to be -0 because the end is the bottom, which is ground. So your total voltage is not V2. Your total voltage you have to add with any other voltage source that you encounter in this loop. And you divide by the total resistance. The total resistance is the sum of these two. So you're going to have the 10 plus 50 to be the total resistance of the circuit on the left-hand side. And that is your equation for the KCL. Then you only have one unknown, which is V2, that you can solve for the V2. Okay, so that would be 15 minus V2 divided by 30 plus minus V2 plus 600 divided by 60 equal to 0. If multiply the whole equation with 60, I got 30 minus 2V2 minus V2 minus 600 equal to 0. So what do I have? There will be 3V2 equal to negative 330. V2 is negative 110 volt. Okay, any question about this?
No, you have to take 600 divided by 60 is 10.
I have the what?
600 divided 60 equal 10. Negative 10. V2 minus
V2 minus 10?
yes.
What do you mean by minus 10? I
Now,
don't get.
when you take out a V2 plus 600 divided by 60,
Divided by 60.
okay, hold on.
You mean this one here?
Yes.
So I multiply 60 on this equation. Oh, this is not, this multiply 60. This is not, okay, so I see I did something wrong here. Sorry. If I multiply 60, this should be 15 times 60. And minus 2 times V2 minus V2 plus 600. That should be the correct one. Okay. Am I right? Any question about this? So that'd be 900 minus 2V2 minus V2 minus 600 equal to 0. So 300 minus equal to 3V2. V2 is 100. Okay. All right. So now once you have the V2 equal to 100, then how do you get the V1? Well, then you can look at what is the I2. If you have a V2 is equal to 100, what is I2 equal to? The I2 is going to be 100 plus 600 divided by 60. Right? So that gives you the current of the total. That would be 700 divided by 60, right? Let's see. Yeah. And then when you have this current, which means you can find a voltage drop between these two, because if the current go in this direction, so this will be positive, this will be negative here. And you're gonna have a voltage drop here. Then you start with 100 volt. You go through this one, you're gonna gain 600. So you have the V2 plus 600, and you're going to have a drop of the voltage. And how much drop is 10 times the current? And then this one will be equal to your voltage at 1. That's your voltage 1. So then you can find the voltage 1 in this case. Okay. All right, so that is the review for today. Any question about this problem here? I go over a little bit, so. If not, then if you have a question, you can send me an email, or you can come to my office hour tomorrow as well. Otherwise, I'm going to see you on Friday morning, starting at 9 a.m. at the GE building 225, the big lecture hall is the place that we're going to give you the exam.
Thank
All
you,
right.
Professor.
Professor.
Uh-huh.
Hey, hello. Hey, Professor.